Yes, it is permissible to run current carrying conductors in a cable tray without them being in a conduit according to the National Electrical Code, specifically NEC Article 392.10 This section explicitly states that conductors are permitted to be installed in a cable tray without the use of raceways or other enclosures. This means that individual conductors or cable assemblies can be placed directly into the cable tray, provided that they meet the other requirements outlined in Article 392 and other applicable sections of the NEC. Let's delve deeper into what this means and what considerations need to be taken into account when implementing such an installation. Firstly, understanding what a cable tray is. A cable tray is a rigid structural system used to support insulated electrical cables used for power distribution, control, and communication. Cable trays are commonly used in commercial and industrial settings because they offer a flexible and accessible way to manage and route large quantities of cables. They come in various materials such as steel, aluminum, and fiberglass, and in different configurations like ladder type, ventilated trough, solid bottom, and wire mesh. Secondly, NEC Article 392 provides comprehensive guidelines for the installation of cable trays. It covers aspects such as uses permitted, uses not permitted, construction specifications, installation methods, and grounding requirements. The allowance of running conductors without raceways directly in cable trays is a significant aspect of this article. It offers a cost-effective and efficient alternative to running individual conduits for each cable. Now let's explore the types of conductors and cables that are permitted to be installed in cable trays without raceways. The NEC specifies the types of cables that are suitable for cable tray installations. These typically include, but are not limited to, types TC, MC, MV, and various other cable types specifically identified for cable tray use. Type TC, or tray cable, is designed for use in cable trays and raceways. It's often used for power, control, and signal circuits. Type MC, or metal-clad cable, is a factory-assembled cable consisting of one or more insulated conductors enclosed in a metallic sheath. It's suitable for direct burial and for use in cable trays. Type MV, or medium voltage cable, is used for power distribution at voltages typically ranging from 2001 to 35,000 volts. It is designed for use in cable trays and direct burial applications. It's crucial to refer to the cable's marking in the NEC to ensure that the cable is specifically listed and suitable for cable tray use without a raceway. Improper cable selection can lead to code violations and potentially unsafe installations. Next, let's consider the support and securement requirements for conductors in cable trays. While conductors can be installed without raceways, they still need to be properly supported and secured within the cable tray. The NEC requires that cables be supported at intervals that prevent excessive sag and maintain proper spacing. Cable ties, straps, or other approved methods can be used to secure the cables to the cable tray. The specific requirements for support intervals and securing methods can be found in NEC Article 392. It is important to adhere to these requirements to ensure the mechanical integrity and safety of the installation. Furthermore, consider the ampacity of conductors and cable trays. The ampacity, or current carrying capacity, of conductors installed in cable trays is subject to varying factors based on the number of conductors in the tray and the ambient temperature. When multiple current carrying conductors are bundled together in a cable tray, the heat generated by each conductor can raise the overall temperature within the tray, reducing the ampacity of the conductors. NEC Table 310.15 cone provides adjustment factors for the number of current carrying conductors in a raceway or cable. These adjustment factors must be applied to the allowable ampacity of the conductors to ensure that they are not overloaded. Additionally, the ambient temperature around the cable tray must be considered. If the ambient temperature exceeds 30 degrees Celsius by 86 degrees Fahrenheit, the ampacity of the conductors must be further derated according to NEC Table 310.15 bone. Proper ampacity calculations are essential to prevent overheating and potential fire hazards. Now let's discuss grounding and bonding requirements. Cable trays must be properly grounded and bonded to ensure electrical safety. Grounding provides a low impedance path for fault current to return to the source, minimizing the risk of electric shock. Bonding ensures that all metallic parts of the cable tray system are electrically connected, preventing voltage differences that could create a shock hazard. NEC Article 392 provides specific requirements for grounding and bonding cable trays. These requirements typically involve connecting the cable tray to the building's grounding electrode system using approved grounding conductors and bonding jumpers. It's crucial to follow these requirements carefully to maintain a safe electrical installation. Let's now talk about cable tray fill requirements. The NEC also imposes limitations on the amount of cable that can be installed in a cable tray. These limitations are designed to prevent overcrowding, which can impede heat dissipation and make it difficult to access cables for maintenance and repairs. The allowable cable fill depends on the type of cable tray and the size of the cables. NEC Article 392 provides specific fill tables and guidelines for calculating the allowable cable fill. It's important to adhere to these limitations to ensure proper ventilation and accessibility within the cable tray. Consider cable separation and management practices. While conductors can be installed without raceways, it is important to maintain proper separation between different types of cables. For example, power cables should be separated from communication cables to minimize electromagnetic interference. Control cables should be separated from high voltage cables to prevent insulation breakdown. Cable ties, dividers, or other approved methods can be used to maintain separation within the cable tray. Proper cable management not only improves the performance of the electrical system, but also makes it easier to troubleshoot and maintain the installation. Next, let's talk about protection from physical damage. Although conductors and cable trays are not required to be in raceways, they still need to be protected from physical damage. Cable trays should be located in areas where they are not subject to mechanical abuse. If the cable tray is exposed to potential damage from forklifts, machinery, or other equipment, it may be necessary to install barriers or guards to protect the cables. In some cases, it may be advisable to use cables with a rugged outer jacket or to install a cover over the cable tray. Now consider the inspection and maintenance requirements. Electrical installations, including cable tray systems, should be regularly inspected and maintained to ensure their continued safety and reliability. Inspections should include checking for loose connections, damaged cables, corrosion, and other signs of deterioration. Maintenance may involve tightening connections, replacing damaged cables, cleaning the cable tray, and applying protective coatings. It is recommended to establish a periodic inspection and maintenance program to identify and address potential problems before they lead to failures or safety hazards. Now let's review the specific wording of NEC Article 392.10(f)(3), which states conductors shall be permitted to be installed in a cable tray without the use of raceways or other enclosures. This sentence is straightforward and unambiguous. It clearly allows the installation of conductors in cable trays without the need for conduit or other types of enclosures. However, it is important to remember that this allowance is subject to the other requirements of Article 392 and other applicable sections of the NEC. In other words, simply because conductors can be installed without raceways does not mean that all other installation requirements can be ignored. All applicable requirements for cable type, support, opacity, grounding, fill, separation, and protection must still be met. Remember that local codes and regulations may impose additional requirements or restrictions on cable tray installations. It is always important to check with the local electrical inspector or authority having jurisdiction to ensure compliance with all applicable codes. The NEC is a comprehensive document, but it is not always exhaustive. Local codes may address specific issues or concerns that are not covered in the NEC. Consider the benefits of using cable trays without conduit. Installing conductors in cable trays without conduit offers several advantages. It can reduce material costs by eliminating the need for conduit, fittings, and supports. It can also reduce labor costs by simplifying the installation process. Cable trays provide better accessibility for maintenance and repairs compared to conduit systems. Cables can be easily added, removed, or rerouted as needed. Cable trays offer better heat dissipation compared to conduit systems, which can improve the ampacity of the conductors. Lastly, cable trays provide a more flexible and adaptable wiring solution compared to conduit systems. However, there are also some potential disadvantages to consider. Cable trays may not be suitable for all environments. They may not be appropriate in areas where they are exposed to severe physical damage or corrosive conditions. Cable trays may not provide the same level of protection from fire as conduit systems. Conductors and cable trays may be more vulnerable to damage from rodents or other pests. It's important to weigh the advantages and disadvantages carefully before deciding whether to use cable trays without conduit. In summary, the NEC does permit the installation of conductors and cable trays without the use of raceways or other enclosures, as explicitly stated in Article 392.10 A3. This allowance offers a cost-effective and efficient wiring solution for many applications. However, it is essential to comply with all other applicable requirements of the NEC and local codes to ensure safe and reliable electrical installation. Remember to select the appropriate cable types, provide adequate support, calculate ampacity correctly, ground and bond the cable tray properly, adhere to cable fill limitations, maintain proper separation, protect from physical damage, and conduct regular inspections and maintenance. By following these guidelines, it is possible to take full advantage of the benefits of cable trays while minimizing the risks. This approach ensures compliance with the NEC and promotes a safe electrical system.